Hello, this is Mr. Miller again, and it's time for video 2A, double reflections and double rotations. What I mean by a double reflection is shown in this kind of figure right here. If we start with the blue triangle and reflect it over line L, we would get the red triangle. And if we take that and reflect it over the second line, line M, we would get the green. So that would be a double reflection. And it turns out in this case, it looks like it was a rotation. If you rotate the blue triangle around this point right here, you would get the green triangle. So double reflection like that is equal to a rotation. So we're going to look at some situations like that. Here we go. So first, some demonstrations. Okay, so I have a geometry program called Geometry Sketchpad here, and it's kind of nice because it does reflections and rotations and translations for us. So the original image is this green triangle, and we're going to reflect it the first time over this first line, and then a second time over this parallel line. So we want to see what happens when we reflect a figure twice over lines that are parallel. So here we go. I kind of just have to select it, have to click on that line to tell it I want to reflect over it, and I just tell it reflect, and voila, there it is. Okay, that kind of makes sense. It doesn't label it for me, which kind of sucks, but I can live with that. It makes sense because it points the other direction. This one's kind of pointing to the left. After reflecting, this one's pointing to the right. So now we're going to do it again. We're going to take the image and we're going to reflect it over the second line. So I hit transform, reflect, voila. So that's the final image. Now, if I look and compare the first one to the last one, we want to think about how we could do that in one step. So if I look at the first one to the last one, I see that they're kind of pointing the same direction. It just got translated, and that's true. In fact, if I move this around, that's going to move around too. So if I move it right here, for instance, I see that this is the reflected one, and the second one looks exactly like the first one. It just got moved to the right. I'm going to move it down again. And even if I move the lines around, I still see that the one on the far right is a translation of this first one. So I can move this line closer. And it moves, but as I move the line, it just moves left and right. So if we reflect a figure over two parallel lines, the result is a translation of the original image. Okay, that was amazing demonstration number one. Here's another one. So this time, this is different. I'm going to do a double reflection, but this time it's over two lines that intersect, and something different is going to occur. So I'm going to select all of that, double click on that line, and reflect it. There we go. There's the first reflection. These 2 points are the same distance to the line of reflection. So are these 2 points. Okay. Now I'm going to take the second one and reflect it again over this line. So here we go. Reflect, and voila. So it's definitely not a translation this time. If I compare the first one to the second one, certainly not a translation. It's a rotation. It's rotated about this point right here that I'm clicking on. All right, now, if we want the angle of rotation, we can measure that. So I'm going to draw a line segment from A to that point and to the matching point over here. And we see that the angle of rotation is kind of a big obtuse angle. It's not 180, but it's pretty big. And I can have the computer measure that. So I'll just tell it to measure angle. And it says 138 degrees. Beautiful. That's this angle right here. So this double reflection resulted in a rotation of 138 degrees. Okay, so if we reflect over two parallel lines, it's a translation. If we reflect over two lines that intersect, holy rotation. All right, we have one more demonstration here. What about a double rotation? Okay, so if I click on this point here and select all of this, I can rotate it. So let me see, I'm going to tell it to rotate, and I'm going to say 50 degrees. Okay, so that's my first rotation. and it rotated 50 degrees about it. That's the measure of this angle. Suppose I want to rotate it, I don't know, 40 degrees more. Okay, I'll select this again and say transform, rotate. And this time I want to go 40 degrees in that direction. 40. Well, if I rotate twice, it's kind of not a surprise. I just get one big rotation. So this first one right here was 50 degrees. It's kind of hard for me to write this way, but maybe I can do it. 50 degrees. And this rotation right here was another 40. So no big surprise if I put them together, rotate 50 degrees and then rotate 40 more, it was a 90-degree rotation. And in fact, you can see that down here. This angle here, oh, it's not going to let me draw any more down there. That angle down here is 90 degrees, this angle right here. Okay, so a 50-degree rotation followed by a 40-degree rotation makes a total of 90. That one's kind of intuitive. So 2 rotations is still a rotation. All right, that's enough of a demonstration here. And we have the conclusions here. So we saw 3 things. Reflecting twice over 2 parallel lines is equivalent to a translation. Reflecting twice over 2 intersecting lines is equivalent to a rotation. And the third one is rotating twice about a point is the same as rotating once through the sum of the angles. Like instead of 50 and then 40, just rotating once through 90 would have been the same thing. Okay, now we want to go a little bit different direction here. And we have just a couple quick examples and we'll be done. We want to visualize and make some predictions. So we could do these steps and find it out, but we want to see if without actually doing the transformations, we can figure out where the triangle will go. So the first one says, which quadrant would the triangle lie in after a reflection over the y-axis and a translation 5 units to the right? So we just got to picture it. And remember the quadrants. So I'll remind you here, this is quadrant 1. Over here is quadrant 2. This is quadrant 3. And this is quadrant 4. If we reflect it over the y-axis, that's right here, it's going to end up over here, around here someplace. And then, if we translate it 5 units to the right, it's still going to be in quadrant 1. So we know this one is going to say Q, or quadrant number 1. Okay? All right. Now, suppose it says which quadrant would it lie in after a 90 degrees clockwise rotation, then a reflection over the y-axis. Okay, so let me erase this a little bit. Okay, now, so if we rotate it clockwise, it would rotate this way and lie in quadrant 1. So it'd be in quadrant 1 again. And then if I reflect it over the y-axis, it would go back to quadrant 2. So, okay, so after those 2 steps, the first step would put it in quadrant 1. Second step would put it back. So it would be in quadrant number 2. So maybe it helps just to think step by step. What quadrant is it going to go to after each step? All right, 2 more quick examples, then I have an assignment for you. Okay, so on this one, which quadrant would the triangle lie in after a 180-degree rotation? It's the same triangle, just different problem. Okay, and then a translation of 8. Well, 180 degrees, well, 90 degrees would put it here, and 180 would put it here. It actually doesn't matter which way you go, whether you go clockwise or counterclockwise with a 180-degree rotation. So it'd be somewhere around here, all right? And then up 8 units. Well, that would move it way up into quadrant 1. That's my prediction. Okay, last prediction. So let me clear the board here. And let me take a look here. Which quadrant would it lie in if it were translated 7 units to the right and then reflected over the y-axis? Okay, 7 units to the right. We'll put it way over here in quadrant 1 someplace. All right, and then if we reflected it over the y-axis, it would put it back in quadrant 2. Okay, so it seems very similar to our first two examples, but that's okay. So quadrant number 2. All right, so step by step, think where it would go after the first transformation, where would it end up after the second one? Okay, it's time for you to try your hand at this. So here's our triangle. We're going to start with RST. And for the first one, which quadrant would the triangle lie in after a reflection over the y-axis? And then take what you get and reflect it over the x-axis. So tell me where it would end up and explain just a little bit. Write a sentence or two. Then, which quadrant would it lie in if it were reflected over the x-axis first, and then translated down 2 units in the same thing? Write a sentence or two explaining it. Okay, thanks for being a good audience. See you later.